Hello guys, welcome to this episode of Learn With Me. In this two-part video, I am going to talk about this right here, the concept of temperature inversion. Like some of you, I was always confused about this whole concept of temperature inversion and found it difficult understanding it until I decided to carry out my own research on it. Now I must say I do find it more comprehensible than before. So I decided to put together this video to help those who probably might be struggling to understand this concept, like I did before. I hope you enjoy it. Let's get into it. Alright, so in the first part of this video, we are briefly going to look at what temperature inversion is. We shall look at its definition, what scientists think about it, and some facts regarding it. Without talking much, let's get straight into it. Also called thermal inversion, it is the phenomenon where temperature increases with altitude in the atmosphere, within the troposphere. This is a reversal of the normal temperature behavior in the troposphere, a region of the atmosphere that is nearest to the Earth's surface, where all the weather takes place. When this happens, a layer of cool air at the surface is overlain by a layer of warm air. What do scientists think about this? Check this out. Scientists thought that normally, temperature decreased constantly with altitude until reaching absolute zero, negative 273.16 degrees Celsius. Absolute zero is the hypothetically assumed point at which all molecular activity ceases. In Fahrenheit, it is 459.69 degrees. Apparently, this is the point where the decrease in the temperature stops. However, the air warmed up occasionally for several thousand meters, sometimes before the normal lapse rate, the decrease in temperature with altitude resumed. It has a varying rate of increase unlike the normal lapse rate, which has a constant rate of increase approximately 6.5 degrees Celsius per 1000 meters, in Fahrenheit 3.5 degrees per 1000 feet. It is the opposite of the normal lapse rate. Of course, if you know about the normal lapse rate, which is a decrease in temperature with altitude, then you know it's definitely its opposite. This is the end of the first part where we looked at what the temperature inversion is, as I said in the beginning briefly. Before we enter into the second part, let me know in the comment section what other term for temperature inversion you know. Alright, so in this second and final part of the video, we shall be looking at how this phenomenon occurs. We shall be looking at the process involved in its occurrence from beginning to end and where and when it happens normally. Without further ado, let's get straight into it. Normally, temperature decreases with increasing heights, but in some cases, it decreases as one moves with altitude. So basically, this is what temperature inversion is all about, as we got to know in the first part of this video. This is common along hill slopes and on calm clear nights, where a less denser warm air moves over a denser cold air. What happens is that during these calm nights, the ground on the hill slopes through radiation rapidly loses its heat energy to become cold. Well, before this can happen, insolation, which is the flow of incoming solar radiation, to the Earth's surface must have taken place already during the day. The ground along the hill slopes must have been heated due to its exposure to the sun and direct contact with the incoming solar radiation. However, with the valley, the solar radiation must have been absorbed by the excessive dust and atmospheric particles present in its atmosphere, preventing it from reaching the ground at its bottom and heating it up, but rather the air inside it. This stable air along the hill slopes subsides down the valley. A stable air is air that is cooler and denser than its surrounding environment. This air resists upward vertical movement, and that's why the cold air along the hill slopes subsides down the valley. However, this denser cold air lays over the less denser warm air already occupying the valley. This causes the unstable warm air in the valley to have buoyancy to rise upwards, leading to rising thermals. As the opposite of a stable air, an unstable air is air that is warmer and less denser than its surrounding environment. This air does not resist upward vertical movement, and that's why the warm air in the valley gets the buoyancy to rise upwards as it is overlain by the cold air, leading to the rising thermals. However, this is not the only thing that happens. As the warm air is overlain by the cold air, its upper part is also cooled as a result. Through the upward vertical movement, the less denser warm air brings the denser cold air down the valley, and its upper part eventually becomes warm again as a result of vertical mixing. So the result of this whole process is that there is cold air in the valley and warm air along the upper slopes. Alright guys, this is where we draw the curtains on this video. I hope you enjoyed it and found it helpful as well. In my next video, inshallah, I shall talk about the causes of this phenomenon. Please, do give this video a thumbs up if you liked it, and don't forget to hit the subscribe button as well for more of this. Stick with me and inshallah we shall meet again in my next video. I'm out.